Let's learn about special right triangles. No, acute triangle, like this. Mr. Armstrong's final geometry class before forced retirement. On our agenda for today, we're going to learn how to simplify square roots because we're going to need that when we discover our special triangle ratios. We're going to compare those ratios and then we'll do a couple practice problems. Let's get ready. You're going to need your notes, pencil, and calculator. One of the things we're going to do with the sides of a triangle is deal with square roots. So we have to know our perfect squares moving forward. So remember, when you square a number, you're multiplying it by itself. So the perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. If you can take the square root of 4, then you get 2. And when we can't take the square root of a number, we want to look for these perfect squares as a factor of those. For example, the square root of 8 is not a perfect square, but it does have a 4 as a factor. So I can rewrite this as the square root of 4 times the square root of 2, and then take the square root of 4 and get 2, and it becomes 2 times the square root of 2. With the square root of 20, I can do the square root of 4 times the square root of 5, and take the square root of 4 to get 2 root 5. The square root of 32, you might think 4 times 8, and that does work because 4 is a perfect square, but it's 16 times 2. You always want to try to find the largest perfect square to be the quicker route. So I'm going to break the square root of 32 up into the square root of 16 times the square root of 2 to get 4 square roots of 2. And the square root of 75 has a perfect square of 25 in it times 3. Take the square root of 25 and we get 5 root 3. So let's move forward back into geometry class. Start with a square. What is true? Well, it is a square, so all the sides are the same, all the angles are the same. When we draw segment AC, that's called a diagonal, and then that is going to be breaking it up into two congruent triangles. So if this is a 90-degree angle, this diagonal is cutting that exactly in half, and we get 45 and 45. So with our squares, we're going to break those angles up into two 45s. And now if we just look at this triangle, this has two angles that are 45, 45, and then a 90-degree angle. Let's use that to find out something within the square. So you can see I have a square with a side of 3, a side of 4, and a side of 5. So we can do each of these and hopefully find a pattern. In the first one with a side of 3, it is a square, so all the sides are 3. I would like you to find the length of AC, which is the hypotenuse of this triangle. So we have two sides. We're trying to find the third side. We can do the Pythagorean theorem. So we're going to do a squared plus b squared equals c squared, which is 9 plus 9, which is 18. And remember, we undo something that's squared by square rooting both sides. So we get, I'm going to switch it around, x equals the square root of 18. And here's where we have to start simplifying our square roots. 18 has a perfect square of 9 in it. So I can divide this up into the square root of 9, the square root of 2, and x ends up being 3 square roots of 2. On the middle triangle, they both have a side of 4. We'll call our hypotenuse x, and do the Pythagorean theorem again. So now we have 16 plus 16 equaling x squared. I'm going to flip it around at this point. X squared equals 32. We're going to take the square root of both sides, and we've already simplified the square root of 32. That has a perfect 16 in it and 2. So when I take the square root of that, I get 4 square roots of 2. And my 5. So both sides are 5. Hypotenuse is x. We'll do the Pythagorean theorem and see what happens. 25 and 25 is going to give us 50. Well, 50 has the square root of 25 in it. And so that becomes 5 square roots of 2. Do you notice anything? The first one had a side of 3 and a hypotenuse or a diagonal of 3 root 2. This one had 4, this one had 4 root 2, this one had 5, this one had 5 root 2. So whatever the side is, the diagonal or the hypotenuse is going to be that number times the square root of 2. So what would this be? Well, we have a square with one side of 100, so the other side would be 100, and this would be 100 square roots of 2. I didn't have to do the Pythagorean theorem because I recognized the pattern. So we call this a 45, 45, 90 triangle. It's identified by the angle ratio, and then it has this side ratio. So the side is 1 to 1 to 1 square roots of 2, whatever that is. So it could be 5 to 5 to 5 square roots of 2. You put the number with the square root of 2. Let's try another. We're going to start with this triangle, and what is true? All the sides are the same, so it must be equilateral. Therefore, all the angles are going to be the same. And we know from our triangle sum that all the angles have to add to 180. Divide that by 3, so every angle here is 60. What we're going to do is we're going to drop the height. And when we drop the height, it's going to be perpendicular. And now we have this left triangle. So I have a 90 degree and a 60 degree. So that means this must be a 30 degree. So let's start to investigate this triangle, 30, 60, 90. So we're going to start with a side of 8, then go on to 10 and 12. So now we're just looking at this triangle right here, not the entire triangle anymore. But I do know that this is a 90, that's a 60, so therefore this is a 30, and we have a 30, 60, 90 triangle. So if this, which is the side of the big triangle, it becomes my hypotenuse. So 8 is my C value. This down here is also 8, and we're going to divide that in half. So this piece of this triangle is 4, and then we have x. So we're going to do the Pythagorean theorem, but make sure you're putting the 8 as the C value. So 4 squared plus x squared equals 8 squared. And then we have 16 and 64. X squared equals 48. We're going to take the square root of that. 48 is divisible by 16. So this is the square root of 16, the square root of 3. And we get 4 square roots of 3. Let's try it with a 10. So I know that just this piece here will be 5. This angle will be 30 for our 30, 60, 90 triangle. I'm going to do the Pythagorean theorem. And we get 25 plus x squared equals 100. So we're looking at x squared being 75. We take the square root of both, and 75 has a perfect square of 25 and 3 of them. So this becomes 5 square roots of 3. And here we have 12, so this bottom piece is 6. This angle is 30. I'm going to do my Pythagorean theorem. And we have 36 plus x squared equals 144. So x squared equals 108. And that has a perfect 36 in it. So it's 36 times the square root of 3. Therefore, x is 6 root 3. Let's see what we notice. This one was 8 and had a 4, 10 and had a 5, 12 and had a 6. So they're all half of it because it comes from the bigger equilateral triangle. So the short side that's across from the 30, that's my shortest side, then I double it, I get my hypotenuse. So then what's the relationship to this side, which we'll call, in this case it's the height, but we'll call it the medium leg. I have a side of 4, and this number is 4 root 3. I have a side of 5, and this is 5 root 3. I have a side of 6, and this is 6 root 3. So the short side times the square root of 3 will give you that medium side. If this is a right angle, this would be 30. My hypotenuse is 200, so across from the 30 is going to be half my hypotenuse, so this is going to be 100. And then across from the 60, I take the 100 and I put it with the square root of 3. I did not have to do any Pythagorean theorem. So this is called our 30, 60, 90 triangle. It's the angle ratio. And now we look at the side ratio. So I always like to start with across from the 30. It's my smallest side, and I'm going to call it 1. Then I double and I go to the hypotenuse, excuse me, and then I go back to the short leg and I put it with the square root of 3 for my medium leg. So it's small to medium to my hypotenuse is 1 to 1 square root of 3 to 2. So let's compare these. we look at them side by side, we can see they both have a square root. They're not the same square root though, so be careful. And in the 45, 45, 90, the square root of 2 is on the hypotenuse, but not over here. It's actually on one of the legs, so be careful because the hypotenuse is double over here. So they both have square roots. On the 45, 45, 90 has a square root of 2 on the hypotenuse, but on the 30, 60, 90, the square root of 3 is on the medium side, and it's the 30, 60, 90 that has a hypotenuse double the short side. So let's practice. Here I have a 45, 45, 90 triangle. So that's the 1 to 1 to 1 square root of 2 ratio. So I have 7, 7. This must be 7 square roots of 2. I don't know these, but these are going to be the same. And my hypotenuse is 12 root 2. Well, there's the root 2, so my leg must be the 12. We're switching over to a 30, 60, 90 triangle. Across from the 30 is the 2. I'm going to double it for my hypotenuse, so u will be 4. And then I'm going to go back and I'm going to put it with a square root of 3 for v. This side is the 30-degree angle. Go over here. Well, that's empty, but I do see my hypotenuse is 16, so y is going to be half of that. And then I can keep going around to the medium side, and this is going to be 8 root 3. So to recap, we have a 45, 45, 90 triangle with a side ratio of 1 to 1 to square root of 2, and our 30, 60, 90 triangle has a side ratio of 1 to root 3 to 2. Nice work.